Hey, welcome back. In this video I'll be covering another type of U substitution integration so that we can solve the integral. But this is called the change of variables. It's slightly different from what we did before with the regular straight up U integration and U substitution. It's slightly different. So the first thing that we're going to change is I'm going to change the steps over here. So the steps are identify U. But once you get U, we're not going to find D right away. We're going to solve for X. So that's the first change. We're going to solve for X. So usually we'd be solving for dx, for du, but we're going to solve for x first. Then we're going to find du and solve for dx. And then this step where you're plugging in cancel becomes more involved. So I'm going to put a star there. So the only change is we're going to pick u, then with our u function we're going to solve for x, then we're going to find dx, then we're going to plug it in cancel. But the plugging in cancel is more intense than before. Then once you do that, we're back to the regular territory of solving the integral. So I'm going to write down 5 examples that we're going to cover right here. Alright, so these are the 5 examples. Now, I'm noticing all of them, we can't easily identify a u, because usually I would pick a u based on if the derivative is there. So if I pick my u to be 2x, the derivative of 2x is 2. The derivative of that isn't really there. Or if I picked here, the derivative, if I pick x, if I pick x minus 7 to be my u, the derivative of that is 1, so I can't really do anything there. Same thing over here. If I pick x plus 4 to be my u, then the derivative of that isn't really there. It goes for all of them. So our old method does not really work. We just have to expand on it a little bit, tweak it, just so that it's going to work. So instead of picking the inside 2x minus 1 to be my u, I'm going to pick the entire square root to be my u. And that's when it's going to work, with some extra step. So whenever you see examples like this, it's using that method. So for this one, let's start. Alright, so I'm going to pick my u to be square root of 2x minus 1. So my u is going to be equal to square root of 2x minus 1. That's the first step. Now I need to solve for x. So to solve for x, I would have to square both sides, because I want to get the x out of the side of the square root. So if I square both sides, I'm going to get u squared on this side equal to 2x minus 1. Now I need to add 1, get my x by itself. So I'm going to add 1 and add 1. Now I get u squared plus 1 equals 2x. Now I just need to divide by 2, and I'll get it. So now it's u squared plus 1 over 2 equals to x. Good. So I solved for x. So I picked my u, and I need to get x by itself. So I squared it, squared both sides, added 1 to both sides so that goes away. Then divided by 2, and now I'm left here. Now, so this is all basically step 1. Okay, now for step 2. We have to solve for x. Solve for dx, rather. So now dx is just the derivative, and that just means solve for dx. So we're going to do that by taking derivatives of both sides. So the derivative of the right side is just going to be derivative of x with respect to x. That's just going to be 1 dx. I'll just put dx. And now we have to differentiate this side. And we're going to get 2u du over 2, which means that u du equals to dx. All I did was cancel out the 2's. Okay, so this is step 2 right here. So first we solve for x, now we solve for dx. Now we need to, we picked our u, we solved for x, this is 2, right? And this is 3, solve for dx, so this is a dx. Now we need to plug in and cancel. But now, this is where it gets trickier. That's why I have the star there. Because this integral is in terms of x. We don't want any x's at all. We already took care of the dx. The dx is equal to this, u du, so that goes away. We already took care of this. This part is just u. Now we need to find out what x is. X is this. So basically we're going to substitute in this integral everything we solved. That way we have no x's at all, and everything has been changed into u's. So it's kind of weird. That's why the star is there. So let me show you. So first, what's x? X is this. U squared plus 1 over 2. In parentheses. What's square root of 2x minus 1? Well, that's our u. That's what it is. So it's basically just playing on equations. You got an equation, so both sides are equal, and we're switching out the x side and taking the u side of it. Now what's dx? Dx is equal to u du. U du. So this integral is equal to this, which is now equal to the integral of, I'm going to pull the 1/2 to the front, u squared plus 1, I'll write it bigger, u squared plus 1 times u is u squared du, which is equal to 1/2. Now I'm going to multiply this out, the u squared times each one by 4. So this is going to be u to the 4 plus u squared du. Just multiplying this times this, that times that. Now I can take the integral of 2. This is something I'm good at. This is something we're good at. We can do this. It's just going to be 1/2 integral of reviving integral. So it's going to be 1/2 u to the 5th over 5 plus u to the 3 over 3 plus c, because it's an indefinite integral. And now we're going to plug back in what we had. So we're going to get 1/2 times square root of 2x minus 1. That's our u. Because now the last step, we're going to go back into x's, just so we answer the problem in the language they were speaking. So they asked us a problem in French. We worked on it in Latin. Now we're going to give them back the answer, but you can't give them in Latin. We got to give them in French, what we started with. So now this is going to be square root of 2x minus 1 to the 5th over 5 plus square root of 2x minus 1 to the 3rd over 3 plus c is the final answer. Now, let me run through it again now. So, first we picked our u. We had this problem. We said our regular substitution just won't work because the root of the inside is 2 and it's not going to cancel out with anything. So we tried to use this new method called change of variables, and we're changing all x's into u's. So first we picked our u to be this whole square root part, square root of 2x minus 1. Had we picked our u to be the inside, it would still work, but I like to just go with this method. It's a more standard way of doing it. Then I said, let me solve for x. And to solve for x is wrapped up in this part of the equation. So I need to get out the square root. I need to add 1 and make sure it's just by itself. So I squared it. It becomes u squared equals 2x minus 1. Then I got to get rid of the 1. So I add 1 to both sides. Now I got u squared plus 1 equals 2x. Now I need to get x by itself. So I need to divide by 2 both sides. I'm left with this. X squared plus 1 over 2 equals x. So I solve for x. Now I got to find dx. And dx is just equal to 2u du over 2, which I can cancel out the 2 to give me u du equal dx. Now this one looks kind of weird, how we did this differentiation. So I'm just going to show you why it came out to be u du. I have enough space right here. So basically, u squared plus 1 over 2 is actually equal to 1/2 u squared plus 1/2, right? Alright, so now if we take the derivative of this, it's going to be 2 times 1/2, and it's going to be used for the 1, equals 2 times 1/2 is 2 times 1/2 times u plus 0, which gives us u 0, 2 plus 0, and 2 times 1/2 u du plus 0 du, which is a 0. So it's going to be u du. So that's why if you break it up into, split up the fraction, you'll see exactly why I got the 2u divided by 2, which is this. So that's step 3, solve for dx. Now for step 4, I need to translate everything into u's. So if it has an x, it needs to go. So x, I already solved. X is this. This whole thing, I call that u. So I just put it in. Dx is equal to this by our work. Now we're back to the old stuff. We just plug it in, cancel, and just go ahead with algebra, see what happens. And we just plug in, this is the x, this is square root of this, and this is dx. And we just pull out the 1/2, multiply by u, multiply these two u's to get u squared. Then I foiled the u squared times this, distribute. U squared times this, u squared times that to give me u to the 4 plus u squared. And then I did the final step of integrating. Since it's just integrating, and I was able to use the exponential rule for that. And I'm going to say this is my answer. Now I could check this answer to see if it's correct. I'd have to differentiate this to see if I get the right answer. But it turns out it's correct. It's kind of a pain to check these just because it's so tricky. But I'll do this one for you. Try to show you how to check it. Alright, so let's make some room. So these are not fun to check, but it's fun when you get it right. Alright, so we need to differentiate this to see if we get that, what we started with. Okay? So we're going to write, matter of fact, let me erase more, because I don't need any of this anymore. Alright, so we need to differentiate this to see if we get that. So let me write it. This is going to be 1/2 square root of 2x minus 1. And first of all, to make my life a little bit easier, if you've got square root of 2x minus 1, that's just 2x minus 1 to the 1/2 power. And it's really this. It's actually 2x minus 1 to the 1/2 raised to the 5th. So that, and then one of the properties of exponents is, when you raise a power to a power, you multiply them. So this is actually 2x minus 1 to the 5/2. And I'm going to just do that for all of them. So this is 1/2 times 1/5. I'm pulling the 1/5 to the front, so divided by 5. And it's going to be 2x minus 1 to the 5/2, because of the square root, plus 1/3 2x minus 1 to the 3/2. Plus c. Now I need to take the derivative of this. And the derivative of this is equal to, I leave my 1/2, it's going to be chain rule. So I need to bring down the exponent, so it's going to be derivative of the outside, I leave the inside. So derivative of the outside is going to be, just bring the 5/2 to the front, 5/2 to the front, leave the inside, subtract 1 from the old exponent, so it's 5/2 minus 2/2, which is 3/2. And then times the derivative inside, so times 2, because that's the chain rule. It's going to be, take the derivative of the outside and leave the inside, then multiply by the derivative inside. So this is the derivative of this one. So this is this. Okay? So now let's do this part. It's going to be 1/3 times 3/2, because I'm taking the derivative of the outside, 2x minus 1, to the 3/2 minus 2/2, which is minus 1. The minus 2/2 is just going to be 1/2 times 2. Got to remember that times 2, the derivative of the inside. And close my parentheses. And the derivative of c is just 0. So I need to plus c. Okay, so now I have some cancellation going on. Nice little cancellation. So this 5, this 5, this 3, this 3, this times 2 and divided by 2, this times 2 divided by 2. So now I'm left with